Good morning, children. So in the previous class, we had started similar triangles. There we had discussed what do we mean by similar triangles. And there I had said that two triangles are said to be similar if they are shape-wise same. Okay. And we had discussed about the conditions. Three conditions were there. First one was side angle side, then angle angle angle, and then side side side. So there I had said that if you have been given two triangles and you want to confirm whether they are similar or not, then you must make sure that out of those three conditions, one must be satisfied by those two triangles. Okay. And thereafter we had discussed basic proportionality theorem, that is BPT. And there I had told you that if you have a triangle ABC, okay, and DE is parallel to BC, then in that case AD upon DB, okay, let me write properly, AD upon DB will be equal to AE upon EC. Yes, this was basic proportionality theorem. And then there was converse of BPT. They said that if you have a triangle ABC such that AD upon DB is equal to AE upon EC, then DE has to be parallel to BC. Yes. So we had discussed about these things, and then we had seen the results on areas of similar triangles. So today we are going to start exercise 12b, and from exercise 12b I am doing question number 3. So question number 3 says that in triangle ABC, so there is triangle ABC, D and E are points on the sides AB and AC respectively. So D is one point on AB and E is one point on AC, such that this DE is parallel to BC. Okay. So in that case, your AD upon DB will be equal to AE upon EC. Okay. So in this question, for question number 3, we have got few sub questions, and so let us see the first one. So your first one says that, like here, you have to consider one diagram. Okay, you have to consider one diagram, and with the help of that diagram, you have to solve those sub questions. Like here, if AD upon BD is equal to 4 by 5, okay, so and EC is equal to 2.5 centimeter, find AE. So here in this question, you can see that triangle ABC is given and D is parallel to BC. So here we will apply BPT, okay, basic proportionality theorem. So BPT means, like here we will have AD upon DB is equal to AE upon EC. So here you can see that for the first one, AD upon DB is already given to you. EC is also given to you. So you can substitute these values and you can easily find AE. Okay. So solution is given. Given D is parallel to BC. Okay. So since D is parallel to BC, so I had explained in the previous class if this DE is parallel to BC, in that case this is small triangle ADE will be similar to bigger triangle ABC. Okay, and also AD upon DB is equal to AE upon EC by basic proportionality theorem. Clear? Now we will substitute the values. AD upon DB is given 4 by 5. AE upon EC, so EC is given. You simplify and you will get A equal to 2 centimeter. Okay, so you can simply pause the video and copy it. Okay. Now see the second sub question. So for the second one, same thing. You have a triangle ABC and DE which is parallel to BC. Okay, and for this question AD is given to you. AD is given how much? AD is given 4. AE is given how much? 8, and DB, that is x minus 4, and EC is given 3x minus 19. Okay, what they want you to find? They want you to find x. Now as DE is parallel to BC, by BPT we will have AD upon DB is equal to AE upon EC. You know each value. Okay, substitute, simplify, and you will get the value for x. Okay, so solution is done over here. Given DE is parallel to BC, since D is parallel to BC, that means this small triangle ADE is similar to the bigger triangle ABC. Okay, and then this AD upon DB is equal to AE upon EC, basic proportionality theorem. Thereafter you know the value for each, so you just substitute. Okay, and simplify, and you will get the answer x equal to 11. Clear? So you can pause the video and you can copy it. Now see the fourth sub question of that question number 3. Okay, I'm not doing line by line. Okay, I'm not going to do each and every question. So see question number 5 here. Again same thing. You have a triangle ABC where DE is parallel to BC. Clear? And in this question AD upon DB is given. Okay, AD upon DB is given, and AC is given. Okay, how much? 18 centimeter. So since DE is parallel to BC, so by basic proportionality theorem we will have AD upon DB is equal to AE upon EC. So AD upon DB is given how much? 2 by 3. Easy for us. Then they have given AE upon EC. Then we have AE upon EC, but we have to find what? AE, and we should have EC, but instead of EC they have given AC. But here you can see that this AC, this line AC is actually what? Sum of AE and EC. Clear? So what you can do is you can write AE upon AE plus EC. Done? Sorry. It will be simply AE. Okay. EC is not given. AC is given. Okay. Clear? AC is given, EC is not given. But we know that AC is equal to what? AE plus EC. Clear? So using this, EC will be equal to how much? AC minus AE. So here we can write AC minus AE. Now we can substitute the value for AC. AC is how much? 18. Okay. Now you simplify and you can get the value for AE. So here I have done the solution for you. Given DE is parallel to BC, since this DE is parallel to BC, therefore this small triangle ADE is similar to ABC. Okay, and by basic proportionality theorem, this AD upon DB is equal to AE upon EC. Done. Here we are looking for AE, so I am denoting AE by X, and then EC, I need EC, so EC can be written AC minus AE, so that would be 18 minus X. Now we will substitute the values for this equation and we will get X equal to 7.2 centimeter. Okay, so you can pause the video and you can copy it. Okay, now let us see question number 4. So here question number 4 says, in a triangle ABC, so there is one triangle ABC. Here D and E are the points on sides AB and AC. So point D, point E. That much. What we are supposed to prove? We are supposed to prove that this DE is parallel to BC. We need to show that. Now when this DE will be parallel to BC? When AD upon DB will be equal to AE upon EC. This is what? This is nothing but converse of Bpt. Converse of Bpt says that this DE will be parallel to BC if AD upon DB is equal to AE upon EC. So let's see the first question. So first question here, this triangle ABC and these points D and E are given, and AD value is given how much? 3, BD value 4.5, AE is 4 and CE is given to be 6. So here we observe that AD upon DB is coming 2 by 3 and AE upon EC is also coming 2 by 3. Okay, so here we observe that these two are equal. If these two are equal, it means that this DE is parallel to BC. Okay, so this implies that AD upon BD is equal to AE upon EC equal to 2 by 3. Hence, DE is parallel to BC. This is due to converse of basic proportionality theorem. Okay, so you will write it down in your maths copy. See second, in this one AB is given how much? AB is given 12, AD is given 8. So this AD is given 8 and AB is given 12. So you can easily find DB. 12 minus 8, this will be 4. Okay, this will be 4 and this is 8. And then A is given to be 12 and AC is given 18. Okay, so total AC is 18 and A is 12. So you can easily find EC, 18 minus 12, that is 6. Okay. Now here you can see that AD upon DB, okay, AD upon DB will be how much? 8 by 4, that is 2, and AE upon EC will be 12 by 6, that is 2. Equal? Yes. So therefore this DE will be parallel to BC. Okay. So here we observe that AD upon DB will be 2, AE upon EC will be 2. So therefore AD upon DB is equal to AE upon EC equal to 2. Hence DE is parallel to BC. The reason is converse of basic proportionality theorem. Clear? Okay, now let us see question number 7. Here question number 7 says that in figure 12.52, so this figure is given to you, this is the figure, and they are saying that in this figure triangle ABC is similar to ADE. So here this triangle ABC, the bigger one, ABC, is similar to this smaller triangle ADE. So if ABC is similar to ADE means what? Corresponding sides are proportional. So you can see that this is the common angle, and since D is parallel to BC, so this angle equal to this angle, corresponding angles, and this angle equal to this angle. Yes. So since ADE is similar to ABC, so what you get? You get sides proportional. So I can write AD upon AB is equal to AE upon AC is equal to DE upon BC is equal to K constant. Yes. And further what they are saying that AD is to DB is 2:3 and DE is equal to 5 centimeter. Firstly we have to find BC, okay, and then if X be the length of the perpendicular from A to D, means they are trying to say that from here if you drop a perpendicular on DE, then this length will be X. Okay, so they want to know what would be the length from here till here. Okay, so I'll just extend this line. Okay, I extend this line and obviously this will be 90. Why? Because DE is parallel to BC. So here 90, so here 90, corresponding angles. So 90 only. So this is a straight line. Okay. So they want you to find this length also. Let's say I denote this by M, this by L. Okay. So let us see how we will do this question. Okay. So see over here. Okay, solution. So this is the figure, okay, and the dotted one I have added later on. Okay, so here they have already said that triangle, the bigger triangle ABC is similar to this smaller triangle ADE. So once triangles are similar, then their corresponding sides are proportional. So here corresponding to AB, corresponding side of AB is AD. So AB upon AD. So here in the numerator I am taking sides of ABC first. Okay. So AB upon AD. Corresponding to BC is D. That's why BC upon D. Corresponding to AC is AE. So I got this corresponding sides. Okay. If you want to write K, say, then you can write. Okay. Now here we are looking for BC, okay, and we have been given AD and DB. So I shall use this one, okay, I shall use this much, okay. So AB upon AD is equal to BC upon D. Now as you can see, this AD upon DB was already given to you. Here AD upon DB was given 2:3. So I can write 2 and here 3. Okay. So this AB will be 5. AB will be 5 and AD 2. BC I don't know, D I know 5 is given. I will solve and I will get the value for BC 12.5 centimeter. Okay. Now what we have to do, we have to find whole length of this AM. We have to find AM, what will be the height. Okay. So here you can see that once you join this A and M, you are getting one triangle like this. Yes or no? where this is A, this is B, this is M, okay, this is 90, this is 90, okay, this is parallel to this, clear, this is 2, this is 3, this is L. So can you see this one triangle is there, ABM, where DL is parallel to BM. Yes, DL is parallel to BM. So I can apply basic proportionality theorem. I can apply basic proportionality theorem. By basic proportionality theorem, I will have AD upon DB is equal to AL upon LM. Okay, so that means 2 by 3, and AL is X given in the question. So X upon LM. Clear? So I can easily find value for LM. So LM will be how much? 3x by 2. So you got LM in terms of x, and you need the total length AM. So you can simply add AL and LM, and you will get x plus 3x by 2. So you will get 5x by 2. Okay. So now let us see. So here ALD, triangle ALD and triangle AMB similar. Why? By angle, because this is common angle, this is 90, this is 90. Okay, and in that case what will happen? Corresponding sides are going to be proportional. So here corresponding sides AL upon AM, AD upon AB, DL upon BM. Done. Corresponding sides. Now we are looking for AM. Okay, so this one involves AM, AD is known to us, AB is known to us, so we will use this one. Okay, so substitute the values and straight you will get AM, or you could have done this way also. Okay, no issue. So you will copy this in your maths copy. Okay, now let us see question number 8. So here it says in figure 12.53, ABCD is a trapezium with AB parallel to DC, given that AB is 4 cm, BC is 3 cm and CD is 6 cm. Question 1. Name two triangles in the figure which are similar. Number 2. Calculate the length of EB. So here this is the triangle EDC, okay, and here AB is parallel to DC. The first question is, which two triangles are similar? So here if you see, this angle E is common for both, this for EAB and also for EDC. It's a common angle, okay, and since AB is parallel to DC, so corresponding angles equal. Okay, so you got two angles equal, yes, in these two triangles. Therefore these triangles are similar. Okay, so we will write triangle EAB is similar to triangle EDC. Okay, so first answer is this, and once these two are similar, okay, then corresponding sides are going to be proportional. So here in the numerator I will write the sides of EAB first. Okay, so here corresponding to EA, corresponding side of EA will be ED, corresponding side of AB will be DC, and corresponding side of EB will be EC. Okay, then you can easily substitute the values and you can get the answer. Clear? So let us see. So here we have been given that AB is parallel to DC. Okay, and now we have to show that which two triangles are similar. So I am taking these two triangles EDC and EAB. Okay, and here I observe that angle EAB is equal to angle EDC. That means this angle is equal to this angle. Okay, corresponding angles. Why? Because AB is parallel to DC. Then I observe that angle EBA means this angle is equal to this angle. Reason is same, corresponding angles. So you can see that two angles are equal. Therefore, these two triangles are equal by this condition, angle, angle, angle. Okay. So therefore, since they are similar, okay, since these two triangles are similar, so corresponding sides are proportional. So EA, okay, EA corresponding to EA is ED. Okay, then EB corresponding to EB is EC. Then AB corresponding to AB is DC. Okay. Now see, we have to find the value for EB. Okay, and AB, BC and CD are given to us. So from this, okay, since we are looking for EB, so we have to take EB, and they have given AB and DC, so we have to use this one. Okay, we have to use this much to find EB. So I have taken it down. Okay, now whatever values are with you, you should substitute. So AB is 4, DC is 6, I have substituted. Now EB I don't know, and we don't have EC. Okay, they have not given EC to us. This whole thing they have not given, EC is not given, but BC is given to us. Yes, and you know that BC is what? EC minus EB. Okay, one second. Let me check. EC. Okay, EC is not given. So for EC what we can do? EC can be written as EB plus BC. Okay, so EB plus BC, substitute the value for BC and then simplify and you will get 6 centimeter. Okay, so you can pause the video and you can write it. Okay, now let us see question number 9. So here question number 9 says, a man of height 1.8 meter is standing 5 meter away from a lamppost and observes that the length of his shadow is 1.5 meter. Find the height of the lamppost. Okay, so let's say this is the lamppost and this is the ground, okay, where the lamppost standing. Obviously lamppost will be straight, that means it will make 90 degree with this ground, okay, this plane, and you are standing here. Even you will stand straight, so you are making 90 degree. Okay, and you are standing 5 meter away from the lamppost, and due to the lamp, okay, your shadow is formed, and that length of the shadow from here till here it is 1.5 meter, and your height is 1.8 meter. Now the question is, what is the height of this lamppost? Okay, so for that what we will do, we will join it like this. So what you see that a triangle is formed, okay, A, B, C, let's say this is D, this is E, and here you can see that this will be common angle for this triangle ABC and ADE, and here 90 degree and here 90 degree. So obviously this triangle ADE and ABC are similar to each other, okay, and once they are similar, corresponding sides are going to be proportional. Yes. So with the help of this we can find the length of this lamppost, that means length of BC, okay. So see over here, this is the figure that I have drawn, okay. So here in triangle ABC and ADE, okay, you see that this is 90 and this is also 90, okay, because obviously this lamppost will be straight, okay. So with the plane you will make 90 degree. Same when you are standing, you stand straight, so you are making 90 degree with the plane, and this angle is common for both, okay. Therefore two angles you can see equal for the triangles ABC and ADE. So by AAA axiom, angle angle angle, these two triangles are going to be similar, so corresponding sides are proportional. So if I take in the numerator sides of this triangle ADE, so if I take AD, okay, then corresponding to AD will be what? AB. If I take AE, then corresponding to AE will be AC. Then if I take DE, then corresponding to that will be BC, okay. So since these two triangles are similar, so you will have sides proportional, that's why it's written sides proportional, okay. Then here what is happening, we are looking for BC, so here you can see that this one involves BC, so we have to take this, and here BD is given to us, AD is given to us, okay, AD DB. So since BD and AD given, that means AB is also given, so we have to consider AD upon AB1, okay. So we will consider this. So with the help of this, okay, we can easily find BC, okay. So now we have taken this, we will substitute the values, okay, and simplify, and you will get value for BC, okay, that is 7.8 meter. Clear? Okay, now let us see question number 11. So here question number 11 says the triangle ABC is right angle at C, okay. So there is one right angle triangle ACB. So at C it is 90 degree, okay. And from P a point on hypotenuse, so hypotenuse will be AB, okay. So from there take one point P and we draw a parallel line PQ, okay, to AC. So here parallel, so when we say it's PQ and AC are parallel, that means sum of these two angles, okay, should be 180. So obviously this will be 90 degree, okay. So if this is 90, that means this is 90. Clear? Now here they have given you AC 2.5, BC, okay, 6 centimeter, and PQ 1 centimeter, and they want you to find BQ and BP. So BQ is this one, okay, it's a part of this triangle. Clear? And here what do you observe, that this angle, okay, this angle is common for both the triangles PQB and ACB, okay, and plus this is 90, okay, and here also 90. So you can see that two angles are equal for these two triangles, okay. So therefore this small triangle PQB and the bigger one ACB are similar to each other, and once they are similar, corresponding sides are going to be proportional. That means BQ corresponding to BQ will be BC, and PQ upon corresponding to PQ will be AC, then BP upon BA, okay, they are going to be proportional. So we got this much, and now we can substitute the values and we can easily find BQ, okay. So in order to find BQ, we have to use this much, okay, because BQ, we are looking for BQ, BC is given to us, PQ is given to us, AC is given to us, so we can easily find BQ. And once we have found BQ, you can see that this triangle is a right angle triangle, so we can use Pythagoras theorem to find this one BP, okay. So this was explanation. Now see the solution. So given AC is 2.5 centimeter, BC is 6, PQ is 1. Now in triangle, this bigger one ABC and this PBQ, a smaller one, this angle is common, and this here 90 and here 90, so two angles are equal. So by angle axiom, these two are similar, okay, and therefore the sides are going to be proportional, okay. So we got this. Now since we are looking for BQ and BC is given to us and AC is given to us, PQ is given to us, so we will use these two, substitute the values, and BQ will be 2.4 centimeter, okay. Now we are looking for BP. So BP is part of triangle BQP. So by Pythagoras theorem, we will have this, okay. Substitute the values and you will get your BP 2.6 centimeter, okay. Okay, now question number 14. So here in question 14 it says the figure, in figure 12.56, AB, here you can see AB, EF, here you can see EF, and CD, this is the CD. AB, EF and CD are parallel lines, okay. Given that AB is equal to 15 centimeter, EZ equal to 5 centimeter, GC equal to 10 centimeter and DC equal to 18 centimeter. Calculate EF and AC. So we have to calculate this EF and this AC. So firstly we will calculate EF. Here you can see that EF is parallel to CD, means this angle will be equal to this angle, okay, interior alternate angles, okay, and here this one is going to be equal to this vertically opposite angles. So here what do you observe, that for triangle EFG, okay, and DCG, two angles are equal. If two angles are equal, the given triangles are going to be similar due to AA axiom, angle axiom, okay. So if they are similar, corresponding sides are going to be proportional. So here if I talk about EZ, EZ contains this and this angle. Now in this triangle, which side contains these two angles, that is GC, so I will write GC. Now here if I talk about EF, so which side contains this angle, okay, so it will be EF upon DC. Then FG, okay, if I talk about FG, then it will be DG, okay. Now so we got this, okay. Now we can easily substitute the values and we can get EF, okay, getting it. So EZ is how much over here? It is 5. GC is 10. EF I don't know, and DC is 18, okay. So 1 and here 2. So EF will be 18 by 2, that is 9 centimeter. So you can easily get your EF 9 centimeter, okay. So you got the value for EF. Now we are looking for AC. Now see, here AB and EF are parallel. That means this angle will be equal to this angle, corresponding angles, and this one is common for both the triangles ABC and EFC, okay. And once two angles are equal for the given triangles, then we say that they are similar and corresponding sides are going to be proportional. So here if I take AB, so AB upon corresponding to AB will be EF. Then if I take AC, then corresponding to AC will be EC. Then I take BC, corresponding to BC will be FC. Now substitute the value. AB is 15, EF is 9, AC I don't know, EC will be 5 plus 10, that is 15. So AC will be 15 into 15 upon 9. So here you can see 3 3s are 9 and 3 5s are 3 1s are, and here 5s are. So you will get 25 centimeter, okay, 5 into 5. So this was explanation. Now see the solution. I will rub this first. I have already explained, just I will show you this. So here firstly we'll consider this triangle, this smaller one, okay, GDC and GEF, okay. So I have already shown you how these two are similar. So this and this same, okay, region is given, vertically opposite angles. Then you can see angle EFG, angle EFG, okay, means this angle and this angle I have shown. You could have written this and this also, no problem, okay, alternate interior angles. Therefore these two triangles are similar by AA axiom. Then the corresponding sides are going to be proportional, and then you substitute the values, okay, you substitute the values and you will get 9 centimeter. Then we are looking for AC, and for that we will consider this triangle ABC and this EFC. So ABC and EFC, angle C was common, angle ABC and angle EFC corresponding angles, so they are similar by the same axiom, by AA axiom, and therefore corresponding sides are going to be proportional. Okay, and then you substitute the values and you'll get AC equal to 25 centimeter. Okay, so with this exercise 12B gets over. Okay,